Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Morpholine, P, is a 6-membered heterocyclic ring containing one oxygen atom and one NH group. Its structure is O, CH2, CH2, NH, CH2, CH2 cyclic. Moving on to the next step. The NH of morpholine is treated with excess methyl iodide to form the N-trimethyl quaternary ammonium salt. The nitrogen gets 3 methyl groups. Then treatment with Ag2O H2O followed by heating causes elimination. The Hofmann elimination removes a beta hydrogen from one of the ethylene bridges adjacent to nitrogen, breaking the ring and forming a terminal alkene. After the first exhaustive methylation, the ring opens to give OCH2 CH2N CH3 2CH is equal to CH2, i.e. 2-dimethylamino ethyl vinyl ether. Let me reconsider. Morpholine ring opening via Hofmann elimination. The nitrogen has 2 CH to CH2 groups, one connected to O and one free. First elimination, quaternary ammonium salt forms. Hofmann elimination occurs preferentially at the carbon beta-2N that gives the less hindered alkene. The ring opens. The nitrogen is connected to CH to CH2O on one side and CH to CH2 on the other side. Hofmann elimination from the CH to CH2 side, not adjacent to O, since O withdraws electrons making those beta-H less acidic, and also the CO bond can break differently, opens the ring to give CH2 is equal to CHN, CH3, 2 plus H to CH2. But ring must open fully. Actually, for morpholine, first Hofmann exhaustive methylation converts NH to N plus, CH3, 3, then elimination opens the ring. The two possible beta carbons are 1 CH2 adjacent to O and 2 CH2 on the all-carbon side. Hofmann elimination preferentially gives less substituted alkene. Elimination from either position opens the ring. If elimination occurs on the carbon not adjacent to O, we get CH3, 2NCH to CH2O CH2CH is equal to CH2. If from carbon adjacent to O, CH3, 2NCH is equal to CH2 plus H to CH2, but that cleaves differently. Moving on to the next step. The open chain product is N-dimethyl, 2,2-vinyloxethyl, amine or similar, containing a dimethylamino group and a vinyl ether moiety. The actual product after first Hofmann on morpholine ring opening is CH2 is equal to CHO, CH to CH2N, CH3, 2-dimethylaminethyl vinyl ether. And for the final step, the dimethylamino group N, CH3, 2 is methylated again to N plus, CH3, 3, then Hofmann elimination of the adjacent CH to CH2 beta-2N gives another elimination. The N plus, CH3, 3, CH2, CH2O, CH is equal to CH2 undergoes elimination to give CH2 is equal to CHO, CH2, CH is equal to CH2, divinyl ether, plus, CH3, 3N. CH2 is equal to CHO, CH is equal to CH2, divinyl ether, which matches option A. Why other options fail? B, would require N to remain in the product, but both Hofmann eliminations expel N as trimethylamine. C and D, would require CO bond cleavage, which does not occur under Hofmann conditions. The oxygen remains in the product. Therefore, the correct answer is A. Therefore, the correct answer is option A.